Thanks for catching that. All right, so we're finishing up the 2.6 notes, and this is number 17 that we left off with yesterday. So just to recap what we've done so far, we had to convert inches and feet on these, and we know that once our answer in square feet down here, so we converted 6 inches to half a foot. We used the side length ratio 0.5 over 10. Of course, 0.5 over 10 is actually the same as 1/20th. We squared the side length ratio to get the area ratio, and we've written these numbers in the blank here. So the ratio was 1:20, or how they wrote it was 20:1. Our ratio we got when we squared it was 1:400, or they wrote it as 400:1. And now we're ready to find the area of the larger merry-go-round. So we're going to have to convert this number, which is also in inches, into square feet. So if I'm going to convert that into square feet, I'm going to have to divide by 12 the same way that I've divided this by 12. 6 by 12 is a half. That's how Jimmy gave us 1/2 for that. And because it's square inches, I'm going to have to divide it by 12 again. So actually you're dividing it by 12 squared, or 144. What is 450 divided by 144? Jacoby. 3.125. Okay. So our ratio for the area of the merry-go-round was 1:400. So for every 1 square foot on the model, it was 400 square feet in real life. So if the area of the model is 3.125 square feet, then the area of the actual merry-go-round will be what? Lizzie, I'm going to have you do this calculation. You've been so helpful so far. What's 400 times 3.125? 1,250. And then we're going to put square feet because the actual merry-go-round is measured in feet. That's correct. That's what made this one challenging. I honestly don't think it would have been a challenging question had they given you the units to be the same. We wouldn't have to do the conversion at the beginning, and we wouldn't have to have done the divide by 12 twice there at the end. So I think it would have been just normal. Number 19 is the last one here. It says a triangle with an area of 10 square meters has a base of 4 meters. A similar triangle has an area of 90 square meters. What's the height of that larger triangle? And so I guess we wouldn't have to necessarily use a picture. They definitely don't give us a picture, but I'm kind of the visual type. And so it might be helpful to have a picture. It doesn't tell us what kind of triangle we're looking at. So I'm going to assume it's just a random one, like the one that I've drawn. And the similar one, if that one has an area of 10 square meters and this one's got an area of 90 square meters, it must be bigger. So I'm just going to make it bigger. I don't know if that's 9 times bigger, but probably it's definitely not 9 times bigger, but we'll just say it's the bigger one so that we can tell them apart. So it says the first triangle has an area of 10 square meters. And it has a base of 4 meters. The larger triangle, which is similar in size, has an area of 90 square meters. And we don't know what its base is, but we can find its base. And then eventually we're going to need to know its height because it asks for the height of the triangle. That's why they italicize that, because you would think base, but they're going with height here. So I can use that to find my base of the bigger triangle. So I know that the area ratio is 10 to 90. Okay, they give you both areas. What is 10 over 90 reduced to? Are you guys done talking to each other? Good. What's 10 over 90 reduced to, Martin? 1/9. Okay. So the area ratio is 1/9. I also know that the area ratio is the square of the side length ratio. course, what's the opposite of squaring a number? Sander? Square rooting it. So what was the side length ratio if they squared it to get an area ratio of 1/9? What must the side length ratio have been? What's the square root of 1 and the square root of 9? Carson? 1/3. So the side length ratio is 1/3. Now, the reason I want the side length ratio is because when they ask me for the base or the height of the triangle, those are side lengths. I don't want to use the area ratio. Now, if they would have given me side length ratio, it would have saved me some time, but they gave me the area ratio. I've got to get the side length ratio from that and then use that side length ratio to fill in my proportion. So if the top, the small triangle and the large triangle have a side length ratio of 1:3, then if the base of the top, I keep saying top, the base of the small triangle is 4, the base, we'll call it B for base, of the large triangle would be what? This is a proportion you should be able to solve in your head. Lucy? Yeah, the base of the larger triangle is going to be 12 meters. So B equals 12. Now, they ask you for the height of the larger triangle. Well, in order to solve this, you're going to need to know how to find the area of a triangle so we can find the height of it. Who knows the area formula of a triangle? Brady, go ahead. Okay. So we know the base of this triangle is 12. We know that you're going to times it by half, or as Brady said, divide it by 2. And then the area we already know is 90. And so we can just fill in and find out what H is. Brady, what's half of 12? Okay. And then so Brady, 6 times what would give you 90, or 90 divided by 6 is 15. Okay, so the height is going to be 15 meters. There is another way you can do it as well. Right as the problem was beginning, before we even did anything else, you could have, knowing that you were going to need the height, you could have actually used the same area formula, and you could have found the height of the smaller triangle. If it has a base of 4 and an area of 10, what's half of 4? Anybody? 2. And 2 times 5 would give you the height. And then instead of using 1 to 3 and then 4 to B, we could have used 1 to 3 and then 5 to H, and that still would have given us the height of 15. So there's multiple ways you could attack this problem. And as long as you use the ratio 1/3, get it right. Now, are there other homework questions over section 2.6 that I can go over? You got one, Owen? 12? Okay, let me go ahead and stop the recording here.